We're going to work on an ALEKS problem that deals with identifying the intermolecular forces between atoms, ions, and molecules. Intermolecular forces are special forces of attraction that occur between atoms and molecules. And there are 4 types of intermolecular forces. The first one is called dispersion forces, and sometimes they're referred to as London dispersion. And these are forces that occur between all substances, whether it's a polar or a nonpolar molecule. And these are considered the weakest forces. Dipole-dipole forces are forces that occur between polar molecules. And hydrogen bonding forces are forces that occur between molecules where the hydrogen atom is bonded to an oxygen, a fluorine, or a nitrogen. And these are strong forces. Ion dipole force are forces that occur between ions and polar molecules, and they are considered to be the strongest forces. Since these forces deal with polar and nonpolar and whether the hydrogen is bonded to an oxygen, a fluorine, or a nitrogen, then we need to have the correct drawing of our structure before we start to determine what type of forces are present. Let's take a look at an example. What kind of intermolecular forces act between a CH3Cl molecule and a CH2CCl2 molecule? So the first thing you want to do is to draw the correct structure. And I want to draw the CH2CCl2 molecule, and they've given us a little hint in the way they've written out the formula. This carbon is bonded to 2 hydrogens, and this carbon is bonded to 2 chlorines. All right, now I want to think about polarity. My CH3Cl molecule is a polar molecule. And my CH2CCl2 molecule, the way I've drawn it out, is a polar molecule. So my chlorine is going to be pulling the electrons towards it. So I've got the polarity. So let's go ahead and think about our forces. The dispersion forces occur in all molecules, whether polar or nonpolar. So dispersion is one of the forces that occurs. We also have 2 polar molecules, so that is the dipole-dipole force, but for ALEKS, they just want us to put a comma and put the word dipole. Let's talk about the hydrogen bonding. We have hydrogen atoms here. However, in this molecule, hydrogen is bonded to a carbon, and hydrogen is bonded to a carbon. So this is not considered hydrogen bonding because the hydrogen needs to be bonded to either an oxygen, a nitrogen, or a fluorine. So these are the only 2 forces that occur between these 2 molecules. Let's take a look at another example. What kind of intermolecular forces act between 2 CH4 molecules? So let's go ahead and draw that out. All right, and these molecules are considered nonpolar. So we said that dispersion forces are going to happen between all types of molecules, whether polar or nonpolar. And these are 2 nonpolar molecules, so dipole forces are not happening here. And hydrogen bonding is not happening because the hydrogen is bonded to a carbon atom, which is not what hydrogen bonding is. So the only force that happens between these 2 molecules are dispersion forces. Let's take a look at another example. What kind of intermolecular forces act between 2 ammonia molecules? Let's go ahead and draw this out. So this is the correct geometry of ammonia. And we want to determine the polarity. This molecule is polar. And now let's talk about the forces. We said that dispersion forces occur between all types of molecules, whether it's polar or nonpolar. So dispersion is going to be a force here. And ammonia is polar. So polar molecule and a polar molecule will have dipole-dipole forces. And let's take a look at this hydrogen atom. Hydrogen in both molecules is bounded to nitrogen. So if hydrogen is bonded to an oxygen, a nitrogen, or a fluorine, that would be considered hydrogen bonding. So between two ammonia molecules, we have three different types of forces. We have dispersion, dipole, and hydrogen bonding. Let's take a look at another example. What kind of intermolecular forces act between a nickel cation, a nickel 2 cation, and a hydrogen chloride molecule? So let's go ahead and come up with a structure. Nickel 2 is nickel 2 plus. And hydrogen chloride molecule looks like this. So this one, the nickel 2 plus, is considered an ion. And HCl is considered a polar molecule. So let's talk about all the forces. So dispersion forces occur between all molecules, whether polar or nonpolar. So dispersion forces occur here. And then we also have an ion with a polar molecule. That would be considered an ion dipole molecule force. We can't say dipole-dipole because we needed two polar molecules. So since this is an ion and a polar molecule, it's considered an ion dipole. Let's talk about the hydrogen bonding. HCl has a hydrogen atom, but it is bonded to a chlorine. So that is not considered a hydrogen bond force. So the forces here are dispersion and ion dipole. Good luck and keep practicing.